Assalamualaikum. My name Muhammad Fahmi bin Muhammad Zuki. I'm from Group 1 and my team and I will present about the chi-square test. So the chi-square test is a statistical method that have been used to analyze category data and determine relationships between variables or difference between observed and expected data. So, in this presentation, we will discuss about two types of chi-square test, which are the chi-square test for independence and the chi-square coordinates of fit test. So, these tests are commonly used in research to make a database decision. So, we go to the case study first.
Hello everyone, my name is Zulhazmi Ifan and today I will present case study 1 on the chi-square test for goodness of fit. So our goal is to see if the age distribution in a small town changed between 2015 and 2020. According to the 2050 census, the population distribution was 30% for less than 18, 40% for 18 to 35, and 30% for greater than 35. In 2020, a survey of 600 people was conducted. The observed results were 2,000 individuals under 18, 2,050 individuals between 18 and 35, and 150 individual greater than 35. Our main question is there a significant difference between the 2020 sample and 2015 population? Here is a quick tip on how to identify this test. We use a chi-square goodness or fit test because we have one categorical variable, which is the age group, and we want to compare a new sample against a non-historical percentage. Now step 1 is to find the expected frequency for our 600 people using the 2015 percentage. For less than 18, 30% of 600 equals to 180. For 18 to 35, 40% of 600 equal to 2040. For greater than 35, 30% of 600 equals to 180. Step 2 is setting up our hypothesis. The null hypothesis H0, there is no significant difference in the age distribution between 2020 and 2015. The alternative hypothesis H1, there is a significant difference. And finally, step 3 is calculating the chi-square statistic or chi-square test using this formula. Here, O is the observed frequency from our survey and E is the expected frequency we just calculated. We will use this formula to find our final test result. That's all from me. Now, let's look at step 4, where we actually calculate our final chi-square value. We do this by plugging our observed data and expected data directly into the formula we just saw. As you can see on the slide, we calculate the variance for each our 3 age group separately. First, for the group under 18, we take our observed value of 200, subtract the expected value of 180, square the result and divide it by 180. Second, for the group between 18 and 35, we take the observed value of 250, subtract the expected value of 240, square it and divide it by 240. Third, for the group over 35, we take the observed value of 150, subtract the expected value of 180, square it and divide it by 180. The observed numbers 200, 250 and 150 come directly from the data matrix table shown yearly in our case study. Next, let's simplify the maths after subtracting the squaring the subtracting and squaring the numbers, we get our new fraction. uh, 200 minus 180 is 20, and 20 square give us 400 over 180. 250 minus 240 is 10, and 10 square give us 100 over 240. 150 minus 180 is negative 30, but when we square it, the negative disappear and give us 900 over 180. And when we divide this fraction out, we get three final values, which is 2.22 for the first group, 0.4167 for the second group, and 5 for the third group. Notice that the third group has the highest value of 5. This tells us that the oldest age group has the largest, most significant shift from what we expected. Finally, we add these three numbers together, 2.22 plus 0.4167 plus 5. This gives us our final calculated chi-square test statistic of 7.6367. In a complete test, we would compare this final value of 7.6367 against a critical value from a statistical table to make our final decision on whether to reject our null hypothesis. That concludes the step-by-step mathematical breakdown for our chi-square calculation. Thank you.
So, Assalamualaikum, my name is Haziq, and now I will explain about the step 5, which is determining the degree of freedom. So, the degree of freedom is an important value in the chi-square test because it helps us identify the correct critical value from the chi-square distribution table. So, this value will later be used to decide whether we should reject or accept the null hypothesis. So the formula of degree of freedom is degree of freedom equal to k minus 1, where k represent the number of categories of group in the goodness of fit test. So in our case study, the population is divided into 3 age group, which is less than 18 years old, between 18 and 35 years old, and greater than 35 years old. Therefore, the value of k is 3. So, substituting into the formula, degree of freedom minus 2, 3, degree of freedom equal to 3 minus 1, which is 2. So, the degree of freedom for this test is 2. So this value will be used in the next step to determine the critical value from the chi-square distribution table. So next we move to step 6, which is finding the critical value. To obtain the critical value from the chi-square distribution table, we need two pieces of information. The first one is the degree of freedom, which we calculated earlier as 2. Second, the significant level or alpha, which is given in the question as 0.05. When referring to the chi-square distribution table, the degree of freedom are located in the left column, and the alpha value are located along the top row. So we locate degree of freedom is 2 and alpha is 0.05 in the table. At the intersection of these two values, we obtain the critical value of 5.991. This critical value will later be compared with our calculated chi-square value to determine the final conclusion of the hypothesis test. So now we move to the final step, which is drawing the conclusion. To make a decision, we need to compare two values. The first one is the calculated chi-square value, which is 7.6367, and second, the critical value, which is 5.991. After comparing this value, we can see that 7.6367 is greater than 5.991. Since the calculated chi-square value is greater than the critical value, we reject the null hypothesis and accept the alternative hypothesis. This means that there is statistically significant difference in the population age distribution between the years 2015 and 2020 at the 5% significant level. Therefore, we can conclude that the age distribution of the population has changed significantly over the last 5 years. So that's conclude my presentation. Thank you.
Moving to the case study 2, we will be looking at how we can use a chi-square test to evaluate the effectiveness of a medical drug. In this scenario, a medical study followed 200 individuals diagnosed with a specific disease to see if the treatment actually works. And the participants were split evenly, and 100 individuals were given the drug while the other 100 received no treatment at all. And ultimately, our goal here is to determine whether there is a statistically significant differences between recovery rates and in the two groups, or if the drug has any real impact on curing the disease. So to break down what actually happened here is, after the treatment period, let's look at the breakdown here. And out of the 100 people who take the drug, 65 were cured and 35 were not. Meanwhile, in the control group, the 100 people who did not take the drug, and 55 were cured and 45 were not. On the surface, we can see a slight difference, with more people recovering in the drug group. However, we cannot just rely on the visual guess. We need to statistically test this hypothesis to confirm if the drug is truly effective. And to do that, our first step is to organize this data into a standard table, which is our observed frequency table. And as shown by the standard formula layout at the top, a table map to distinct group against two distinct outcomes. And in our case, row represent the outcomes and cured versus not cured, and white while the column represent our two group, which is drug versus no drug. And this clean structure gives us the exact observed frequencies we need to calculate our chi-square test statistic and find out the final answer. Thank you.
Hello, Assalamualaikum. My name is Nur Aiman. I will further explain about all of the steps in the chi-square methods. So for the step 2, we need to make the hypothesis statements. Based on the question scenario, the null hypothesis, which is HO, will be there is no associations between taking the drug and being cured, which means the drug has no effect to the patients. And the alternative hypothesis, which is H1, will be vice versa with the null hypothesis. So the alternative hypothesis will be there is an association between taking the drugs and being cured, which means the drug has an effect to the patients. So for the step 3, we need to calculate the expected frequencies. As the formulation in the slide presentations, first we need to identify the row totals, column totals and the grand totals. How the formula works? The formula work with row totals multiplied with column totals, and then it will be divided with grand total to summarize the expected frequencies. As the table shown in this slide presentations, the expected frequency we get is 60 and 40. How do we get the expected frequencies? First, we need to refer the observed frequency table, which has data of all of the totals that we need to make the calculations. So for the cured persons, the row total, which is 120, will be multiplied with 100s equal to 12,000, and 12,000 will be divided with 200s. So the total is 60. 60 will be the expected frequencies for the data. It's also the same with the not cured data, which is 80 multiplied with 100 equal to x thousand. 8,000 divided with 200 equal to 40. So that's how we manage to calculate the expected frequencies. So we move forward to the step 4, which is calculating chi-square statistics. The formula shown in the slide presentation, which is x2, the test statistic, is equal to the sum of observed frequency minus expected frequency power of 2 divided with expected frequencies. So all of the data that we get from the observed frequency table and expected frequency table will be filled in the formula. That's why the calculation will be 65 minus 60 power of 2 divided by 60. 65 is the number that we identified from the observed frequency tables, and 60 is a number that we provide from expected frequencies tables. So the calculation further or continue with 35 minus 40 power of 2 divided 40 plus 55 minus 60 power of 2 divided with 60, and 45 minus 40 power of 2 divided with 40. So the calculation will continue step by step until we get a data which is x2 equal to 0.4167 plus 0.625 plus 0.4167 plus 0.625. So the final number or the final summarize will be x2 equal to 2.0833. So for the step 5, we need to determine the degrees of freedoms. So the degrees of freedom later will be used in the step 6 to find the exact critical value for the data. The degree of freedom formulas are simple, which is number of rows minus by ones and multiply with the numbers of column minus by ones. So with the question scenario, we already identify that number of rows and number of columns are 2. So we fit it in the formula, which is degree of freedom will be 2 minus 1 multiply with 2 minus 1. So the final answer for degree of freedom will be 1.
So next, for step 6, we determine the critical value. So using a significant level of alpha equals to 0.05 and degree of freedom, df equals 1 we refer to the chi-square distribution tables. So by finding the intersection between df equals to 1 and alpha equals to 0.05, we obtain the critical value. So therefore the critical value is 3.841. So for the last step, this is for step 7. So we made the conclusion based on the calculate chi-square statistic and the critical value. Since the calculated of chi-square statistic, which is 2.0833, is less than the critical value of 3.841, so we fail to reject the null hypothesis HO. So therefore, we accept the null hypothesis, which indicates that the drug does not have a significant effect on curing the disease. In the conclusion, the chi-square test is an important statistical method that used to analyze a category data. So, we have discussed two types of chi-square, which are the chi-square test for independence and the chi-square for the correctness of fit test. So overall, this test help research make clear and objective decision based on categorical data. So that's all from our group. Thank you.